afternoon. Welcome to Algebra 2. We're looking at lesson 9.3b. It's a paper submission due on Monday. So reviewing from the homework, if you have canceled factors, then that tells you where the holes are. We're going to look at different types of horizontal asymptotes. There's three cases that we're looking at today. And I know there's a lot of information in this paragraph, but what it boils down to is this. Every rational function is either top-heavy, balanced, or bottom-heavy by degree. This one's bottom-heavy. How do we know? Because the degree in the bottom, the denominator, is more than the degree of the numerator. Eyes up here. Go ahead and take a look at this one. It says degree 1 over degree 2. When you have a higher degree in the denominator, we call that bottom-heavy. Here, it's degree 2 over degree 2. So this one is balanced. The last one is top-heavy. Whenever the degree of the numerator is greater than the degree of the denominator, we say that rational function is top-heavy. So when you look at a rational function, yes, the degree of the numerator is less than the degree of the denominator. Basically, it's bottom-heavy. When that happens, the horizontal asymptote will be y equals 0, no questions asked. If it's balanced, degree 2 over degree 2, or maybe degree 17 over degree 17. When the degrees are balanced, then to find the horizontal asymptote, you have to take the leading coefficient up top divided by the leading coefficient down below. So the horizontal asymptote formula will be a over b, where in this case, a is equal to 1, b is equal to 3. If the rational function is top-heavy, that is, if the degree of the numerator is greater than the degree of the denominator, then there is no horizontal asymptote. You will have an asymptote, but it just won't be horizontal. So, just want to give you an idea of how to do that. There's, let's jump right into the first example. In this example, the horizontal asymptote is going to be 0 whenever it's bottom heavy. Are any of these bottom heavy? Scan through A, B, C, D, E, and F. Look at those 6 functions. If you see a function that's bottom heavy, put its horizontal asymptote equation right under HA for horizontal asymptote. Okay, tell your fellow group members which ones are bottom heavy.
Said E.
A, B, C, D, E, or F, if any.
A, C,
Do we have any bottom heavy?
A, C, and E. What did you say? A, C?
All right, raise your hand if you think you know a complete list of functions that are bottom heavy, where the degree of the numerator is greater than the degree of the denominator, or rather, where the degree of the denominator is greater than the degree of the numerator. Which ones are they? Owen, go ahead. A is bottom heavy.
B.
B is not bottom heavy because the degree of the numerator is 1 and the degree of the denominator is 1. So this one's balanced. Are there any other that are bottom heavy?
C.
A and C are bottom heavy. Are there any others?
E. And I can't really see.
It's on your paper.
Yeah. A, C, and E.
A, C, and E. So for those 3, the horizontal asymptote is y equals 0. Now, there's a concept here. Whenever it's bottom heavy, then what that means is that as we approach infinity, the horizontal asymptote, by the way, does tell you what the end behavior of the function is. It tells you as x approaches infinity or negative infinity that, let's take x's that get big, like 100, 1,000, 4 over 1,000,000 minus 3. Look, the denominator, if it's bottom heavy, is going to grow much faster than the numerator, and so the overall value of the fraction is approaching 0. That's why when a function is bottom heavy, its horizontal asymptote, which is a descriptor of its global behavior, goes to 0. Any questions on why A, C, and E all have a horizontal asymptote at y equals 0? The ones you get to skip are those that are top heavy. Are any of these top heavy, where we can just say none in terms of the horizontal asymptote? Raise your hand if you find a fellow group member who agrees with your list of functions that are top heavy. All right. Jonathan.
F.
F is top heavy, so horizontal asymptote we would say none.
Yeah.
Are there any other top heavy? No. The rest are balanced. So for the ones that are balanced, the horizontal asymptote is y equals the ratio of lead coefficients. In this case, 1/3. Would you please write down the, write down the equation of the horizontal asymptote for letter D. What is the equation of the horizontal asymptote over there? These are not vertical asymptotes. These are horizontal asymptotes. All right, let's go with Imani. Letter D. What's the equation of the horizontal asymptote? 3/1 is correct. Y equals 3/1. You ignore the 5 and the -2 to find the equation of the horizontal asymptote. Just y equals the leading coefficient upstairs divided by the leading coefficient downstairs. Any questions on example 1? Yes, go ahead.
For F on the top, would you just like distribute it?
Doesn't matter, the point is it's degree 2. Since you have degree 2 over degree 1, it's top heavy, therefore there will be no horizontal asymptotes. All right, so let's go on to example 2 where we do an actual example of this. So there's 4 steps. First we factor. Poles go first after you factor, then vertical asymptotes, then horizontal asymptotes. You got to go in that order. So factoring, this one actually has a typo in it. The original equation should be y equals x minus 2 over x squared minus 6x plus 8. So please change the original problem to x minus 2 over the trinomial x squared minus 6x plus 8. When you factor the denominator, you get 2 binomials. Go ahead, review your factoring. What is a factored version of the denominator going to be? Go ahead and try it. Okay, how did you end up factoring the denominator? Jay?
X and X.
Right, so what's the first binomial?
X plus 1.
I need 2 numbers that multiply to 8, but add up to -6.
2. X plus 2.
We have x plus 2
And then X plus 4.
and x plus 4. Those 2 numbers multiply to 8. They add to +6. We're going to need a -6 for outers. Right now, your outers plus inners gives you +6. What adjustment can you make?
Change both plus signs to negative.
Yep, that'll do it. Change both plus signs to negative, and we have a correct factorization. Now, I would like you to indicate the cancellation that occurs. For me, I've been doing the cancellations in yellow shaded, and then write the simplified answer. Upon cancellation, what we have is y equals nothing left upstairs except for the number 1 over x minus 4. You'll see on the homework solutions, which are already posted, that upon cancellation, we're going to write the equation of the function, because being parent focused here, now we can see that the parent graph we're dealing with in this function is y equals 1 over x, and we're going to shift it right forward. So even though there's going to be a hole in this child graph, it will be a child of the 1 over x parent function. It'll be shifted right forward. What is the x coordinate of the hole in the graph? Mia?
4.
Now, you actually defined it. Can you tell me what the canceled factor is? Yeah, the canceled factor is a binomial. It's shaded in yellow.
X minus 2.
Yeah, so what you do is you take x minus 2, go ahead and write this down, set it equal to 0. To find holes, you always take the canceled factor and set it equal to 0. When you solve that for x, what do you get?
2.
You get 2. So there's a hole at x equals 2. Today, we're going to have to take it a step further. Not only do you need the x coordinate of the hole, but you need the y coordinate of the hole. Jonathan, how do you think we're going to find the y coordinate of the hole?
Type in your calculator.
No, we're going to do it right here in this green boxed equation. Put the x coordinate of the hole in for x. So put a 2 in for x. To what does that fraction simplify? 1 over negative 2. Let's call it negative 1/2. So there is a hole at 2 comma negative 1/2. Let's put it in right now. Plot the point 2 comma negative 1/2 with a circle. There's a hole in the graph right there. Now, does anyone have any questions on how to locate the hole at the point 2 comma negative 1/2? Yeah, Gerald.
Wait, how do we do the negative 1/2?
Now, what Jonathan did was he took the x coordinate of the hole and he plugged it in for x, not here, not in the original, because in the original that would give us division by 0.
Yeah.
But in the simplified version, after the cancellation, notice that 2 minus 4, that's negative 2, and 1 divided by negative 2 is essentially negative
Okay.
1/2. So that's what's going on there. Any other questions on how to locate the hole at 2 comma negative 1/2? Next, we're going to go for the vertical asymptotes. Now, we showed the work for getting the hole, but you might be able to do that work in your head. How many of you, just raise your hand, I won't announce your names on YouTube or anything, but raise your hand if you think that you'd be able to get the x coordinate of the hole without showing your work. Feel free to do that. Same thing, vertical asymptote. I mean, you're spying this. You see this factor here. What does this factor down here tell you about the equation of the vertical asymptote? Raise your hand if you're reasonably sure you know the message being sent by this factor. All right. Andrew.
Oh, vertical asymptote is 4.
The equation. All equations
Oh.
have equal signs.
Oh, x minus 4 equals 0.
No, but what's the equation?
X
Once you,
equals 4.
yeah, what we're looking for is x equals 4. So, any questions on how to just look at the original problem in factored form and conclude that there's a vertical asymptote at x equals 4? Let's install that into the graph. At x equals 4, please draw your vertical asymptote labeled with an equation now. For horizontal asymptote, this is where we lean on our analysis of top-heavy, balanced, or bottom-heavy. You can look either at the original or at the simplified version. Which is it? Top-heavy, balanced, or bottom-heavy? What say you, Thomas Gonzalez? Top-heavy, balanced, or bottom-heavy? Which is it? Bottom heavy is correct. It's degree 0 over degree 1. That's bottom heavy. Therefore, what is the horizontal asymptote? What's the equation of the horizontal asymptote for every bottom heavy rational function? That's y equals 0. So, would you please sketch the graph of the horizontal asymptote y equals 0? That's called a skeleton of the graph. It's got all the key features. Now, all you have to do is fill in the blanks. In fact, you can probably see from here that if you got a hole here, the graph is going to contain the hole and just continue like that. Now, what's going on over here? If you want to know what's going on over on the right-hand side, let's put in numbers like 5 or 6. So let's set up a little TXY, or a little XY table where we put we're curious about golf ball 5. Just one number to the right of the vertical asymptote. When you put a 5 in for x into this simplified version, it's a good thing we wrote this down in the green box. We get 1 over 5 minus 4. It's 1 over 1. Golf ball 5 goes up to 1. And that's really all we need to see the shape of what's going on. You get full credit for placing golf ball 5 at a height of 1. 1 over 5 minus 4 goes to a height of 1. Any questions on how to complete the graph in example 2? Yeah, the hole kind of tells us where this branch is located. And oh, by the way, we could have obtained this red graph by simply taking the parent graph, which is 1 over x. I'm going to give a little indication of where the parent graph hyperbola is located. It's right there. Do you agree that this blue parent graph of 1 over x, when shifted right 4, we go 1, 2, 3, 4, so we could have made this even more precise. 1, 2, 3, 4. So we could have skipped the put a 5 in for x, solve for y step by simply moving the parent graph 4 units to the right. So it's an alternate way that you could have located this red graph. Are there any questions on example 1? Now, I just want to let you know that I have a sense of pace with this lesson. We're ahead of schedule. So if we finish this back page in good time, I think you'll be in a fantastic position to finish the homework in class before we go. We got 2 more examples. Let's see if we can knock these off. 9.3b. You've got a factoring task facing you here. Would you please factor the numerator? If you're thinking, I'll bet there's an x plus 3 in there because they're probably going to have a cancellation. You know, that's not a bad guess. Not a bad guess at all. They usually pre-cook these problems so that you can get a whole, and this case is no exception. Fill in the x and y coordinates of the whole, and oh, by the way, this is not a child of 1 over x. This time, it's a child of parent number 1, not parent number 10. It's 1 over x. I know we've been calling it parent 9, but let's just admit it, it's parent number 10. So instead of going 7, 7.5, we'll just go 1 through 10. There's 10 parent graphs in this course. So it's really a child of y equals x. The parent is y equals x. So it's instead of a hyperbola with a hole in it, it's going to be a line with a hole in it. What is the x coordinate of the hole in the graph? What's the x coordinate of the hole? Daniel.
2.
No. What's the procedure for finding the x coordinate of the hole?
I'm not.
Now, do you remember what on this previous problem, I had asked a student to find the x coordinate of the hole? We came up with 2. Were you watching during that part of the show?
Yeah.
Okay, what did we do to get x equals 2 on this one? What?
No, the highlighted ones, right?
What did we do to the highlighted factor?
You like cancel them out.
Yeah, but how did we get x equals 2 out of the highlighted factor?
Divided.
No.
Gosh.
We always set the highlighted factor. This is where we showed the word. Did you copy down this word too?
Yeah, I did.
See what we did to the highlighted factor? This might help. Check this out. Always set the highlighted factor equal to 0 and solve for x. That's how you find the x coordinate of the whole. So let's do it again. Daniel, you're on.
It would be 3.
For the world to watch. I'm sorry, it's what?
Would it be -3?
It would be -3. Woo-hoo! Now, using the simplified version, the green box version, what is the y coordinate to the whole? Lauren. Thanks to your friend Daniel, we have the x coordinate of the whole at -3. What is the y coordinate of the whole? -1? Raise your hand if you agree with -1. Thanks, you can put your hands up. It's correct! It is -1. We've got a hole at -3, comma, -1. Draw the circle at -3, comma, -1. Houston, we've located the hole.
Wait, how do we get -1 again?
Would you explain, Lauren, would you explain how you got -1?
I put like the -3 back into the y equals 2.
She put a -3 back into the y equals version of the equation. Notice the simplified version of the equation, not the original. If you put a -3 in the original, whoo, you got division by 0. But if you put -3 into the green box version, you get -1. Are there any other questions on how to get the hole's location coordinates? Draw the hole in the graph. Oh, by the way, there's no vertical asymptote. Look, after cancellation, there is nothing in the denominator. Horizontal, vertical asymptote, none. Horizontal asymptote, this thing's, it's not a rational function. Upon cancellation, it's a linear function. None. All we have here is a line. Now, back when you were, the first time you looked at equations of things like y equals x plus 2, probably back then, you did not think of vertical shifting by a factor of 2. You didn't think parent graph y equals x shifted up 2. But now that you're in algebra 2, you can look at y equals x plus 2 as a vertical transformation of this parent. Oh, here it goes. Get ready. Shift this line, shift y equals x up 1, 2. It went right there. It worked. Check this out. Now, if you do it that way, if you selected the line y equals x and then shifted it up 2, you should change, you should select white and then go over the blue part that's inside the hole, make it look like it's actually a hole. Any questions on this one? Question, go ahead.
Wait, how is there no horizontal asymptote?
Well, it's not a rational function. The only time we talk about horizontal and vertical asymptotes are when the green box equation has something in the denominator, a variable expression in the denominator. There's no variables in the denominator. They canceled out. So there's no horizontal asymptote, no vertical asymptote. Further questions? Yes, Gerald.
How do we know that the parent graph is y equals x?
It's because, try covering up the x, the plus 2. Because that's the up.
Mhm.
1, 2, so it's like, there's nothing there but x. So it's like on all these, if you had any of these on yesterday's lesson, this is what you missed yesterday, Mason. You took all the parent graphs, you have the hand up for that. Took all the parent graphs, instead of going up 2, Gerald, we went up 1. So if you want to find a parent, if this were given to you, to find out what the parent is, take off the up-down shift, take off the plus 1, take off the reflection, take off the right, left, and what's left? X squared. Absolute value x, square root x. So you can tell what the parent graph is if you shave off the reflection portion, the up-down shift portion, and the left-right shift portion. Then the parent will be revealed. Further questions? Just trying to get extra views. Yeah, go ahead.
Back to example 3, like how did you know to shift up with it? Is it because of that y equals x plus 2?
Now your question assumes I'll even be able to find example 3. Wait, were you asking about example 3?
Right there.
This one.
Yeah, back
Yes, your question is what?
to, like, how do you know to shift the line up?
It says right there, plus 2.
Yeah,
Up
that's
2.
what.
Or, you know what else you could do? You could say, whoa, back in algebra 1, we learned that y equals x plus 2 is a line with slope 1 and y-intercept 2. So check this out. I mean, the standard algebra 1 approach to this would be intercept is 2, and then the slope is 1. So up 1 over 1, up 1 over 1. So intercept 2, slope 1. That's another way to look at it. All right, and now for our last example, before we turn you loose. The factored form of example 4 involves, a denominator that is a difference of squares. X squared plus 1 does not factor, but this is x squared minus 1. It's a difference of squares. So, Jack, what is the factored version of the denominator? It's a little factoring review for you.
Can't you not factor it?
If it were x squared plus 1, like a squared plus b squared, cannot be factored. But a squared minus b squared does factor.
X plus 1, x minus 1.
There it is. That's it, Jack. It's x plus 1 times x minus 1. Now, kind of makes you wonder, is there one of those in the numerator? Because they usually love it when these things cancel. They love having common factors that cancel out, producing wholes.
Wow. Oh.
But the question is, do you think it'll be an x minus 1 whole or an x plus 1? Yeah, because of all the pluses upstairs, I'll bet you it's going to be a plus 1. Which means that's going to make, wait, does this work? 2x plus 3. We have a whole. So, go ahead and finish the problem from there. Actually, just get the equation of the whole or the coordinates of the whole. Because honestly, this is the hardest problem that we've seen in this course when it comes to find the coordinates of the whole. Now, honestly, it's not too hard to find the x-coordinate of the hole. What is the x-coordinate of the hole? Class?
X minus 1. X equals what?
X equals
-1.
x equals -1 is correct. Oh, nameless person. And then the question is, what is the y-coordinate of the hole? The y-coordinate of the hole. Well, to find out, let's look at the green box equation. Now, the green box
I just
equation.
want to say, before you said Tommy's whole name, so.
Yeah, you said Gerald too, and
His
Alana.
first and last name.
No, yeah, but they didn't just give an incorrect answer.
What?
If someone gives an incorrect answer, then I'm not gonna say their name.
I was giving the correct answers.
I mean,
Oh,
So you say
so, yeah.
I
So,
respect that.
ladies and gentlemen, here's your task. Put -1 in for x in the green box equation. What is the y-coordinate of the green box equation when x has a value of -1? So what do you think on that one? Sophia. Well, how about just the numerator? What's the numerator when x is -1? 1 is correct. So we got 1 over -2, it's -1/2, so we've got a hole located at -1, -1/2. So put the hole in first. By the way, notice that this is a rational function. Rational functions typically look like children of 1 over x, so we can expect 2 branches. The vertical asymptote's got to have an equation of x equals what? Raise your hand if you're reasonably sure you know the equation of the vertical asymptote. Let's go with Alana, go ahead.
Is it 1?
X equals 1 is the answer provided by the student named Alana. Raise your hand if you agree with x equals 1. You said her name. You said her name, it must be right. It is correct, x equals 1. So, x equals 1, let's put that in. Vertical asymptote labeled with the equation x equals 1, and the horizontal asymptote requires that we know whether this green box equation is top heavy, balanced, or bottom heavy. Mason, would you say this is top heavy, balanced, or bottom heavy?
Balanced.
Balanced is Mason's answer. Raise your hand if you agree with balanced.
Yes.
So his name is going to be green. It is balanced. So what is the equation of the horizontal asymptote, please? J. What is the equation of the horizontal asymptote? Mason helped you out here. Mason said it's balanced.
So is it 2?
It's got to have an equal sign. Y equals 2 is correct. So,
That's it, Jay.
Jay, that's correct. Okay, so now, what I'd like you to do is draw the branch that goes down here, the branch that includes the hole. And honestly, as long as you just get the general shape of it, honoring the asymptote, make sure that the graph gets closer and closer to the asymptote as you go, then you're fine. Now, to find out what's going on the other side, would you please set up a mini XY table to see where golf ball 2 lands? At what altitude is golf ball 2 defiantly hovering? Use the green box equation to discover the unexpected answer. Whoa, is it really? Could it be 7? Golf ball 2 is all the way up at 7. Draw the other branch, you're good to go. The homework 9.3B is due on Monday. Have a good weekend.